Hi, this is Stu from Continuata AI. We've been looking closely at some difficult challenges across the UK public sector, places where we think AI could have a meaningful difference on things like waiting lists and reducing administrative pressure, ultimately leading to a better service for the people of the UK. Recently, we've been looking at challenges on Gov.uk, and one area really stood out to us, the Department for Work and Pensions, the DWP, specifically the process around personal independence payments, PIP. PIP helps adults with the extra costs of living with long-term illness, disability or mental health conditions. But the way eligibility is assessed is slow, it's very manual, and it's creating significant backlogs for both applicants and staff. In this video, I'll walk you through a prototype that we built to explore how AI could make parts of this process faster and more consistent. We've focused on two key problems, and in this video, we'll look at the first one. Let's dive in. First, let me set out the problem itself. Here we've got a sample of the PIP2 form, how your disability affects you. It's a central part of the assessment process, but it has several major challenges. So it's long, it's more than 40 pages. This is including a preamble here, but when we actually see the form, it starts here, it's big. It's often handwritten by the applicant, so it needs processing by somebody who can read that and understand the handwriting. Answers vary widely and often complex, inconsistent, or hard to interpret. Caseworkers have to manually read, extract, and understand all that information, and then they must map it to the official PIP scoring descriptors, which is a specialized and time-consuming task. With the volume of forms arriving every day, this creates long processing delays, often 10 to 20 weeks from submission to completion. A real risk of inconsistent scoring, frustration for applicants, increased pressure on the DWP teams, and as of May 2025, there's around 392,000 reviews still outstanding. This is exactly the kind of problem that AI can help with. Our hypothesis is simple. If we automatically process the PIP2 form using OCR and AI interpretation and turn handwritten narrative answers into structured data, then we can accurately score the form using the official PIP criteria. This will reduce caseworker workload and help clear backlogs faster. The idea isn't to remove people from the process, but to free caseworkers from the repetitive extraction work so they can focus on the complex cases and decision making. This is the first of the two problems that we tackled. Here we are on our website. We're going to take you down to the design challenges section, and in here we track the progress of the different challenges that we've set ourselves. And as you can see, we have delivered these two. This is the form analysis one that we care about right now. So I'm going to take you through to this page. And what this is going to show you is the full breakdown of the problem that we're solving, what the proposed solution is, how we went about it, and what the motivation behind it is. Then we'll do a demo and we'll show you some of the output and how we've evaluated that. So here's where this challenge sits in the whole PIP process. It's at the form reviewed section. The PIP2 form comes in as a handwritten document, and caseworkers must manually read, interpret, and score it. So what we're exploring is whether AI can take on the repetitive extraction work without changing how decisions are made, but speeding up how the information gets prepared for caseworkers. Let's get on and have a look at the demo. Okay, let me show you how the prototype works then. So on the right, you'll see we've got a PIP2 form that's been filled in. We created our own version of this form because the only ones that we could get hold of are the ones off the website that have a sample watermark over them. So what we did is we reverse engineered the form in our website using HTML, and we were able to get quite close to the form style because we had the GDS fonts and things like that. So it wasn't much effort for us to create a partial form. We've emulated a few of the sections, not all of them, just to give us a good idea of how this is working. And so on the left here, you'll see our tool. We've got two functions here. The call analysis one is the second part of this problem that we're going to get to in our next video, and this is the one that we care about here. The way the PIP to form analysis works is we click on this, we choose a file, and we process it. What's going to happen is that it's going to go through the different stages of processing. It's going to go through an analysis stage of OCR, and then it's going to do an LLM analysis stage, and then it's going to do a scoring stage. And so we've got those kind of three things back to back that happens to make sure that the quality's high, and also to ensure that the structure is maintained so that we can do an accurate score. I'll show you the results, and I can explain a little bit about how it works, but you might be wondering what this original text is here down here. So when we created our form, what we did is we got GPT to generate a fake persona and a set of conditions, which then it created a script for us to fill in the PIP2 form. And we used that script and we followed it word for word, copying it into the form, but we put in mistakes, difficult to read handwriting and things like that. So you should be able to see here, some of the words are pretty hard to read. It's not a very high quality scan either, so we're making it difficult for ourselves. As we get down to the bottom, we get the narrative, and this is the difficult bit for the OCR to read, not just because it's hard for it to recognize words, but typical OCR finds it hard to understand the context of what's being written about, and like if you're reading a birthday card from a relative with really poor handwriting, it helps to know what the context is for the message that's being sent to you, so you can figure out what this specific word is that you're stuck on could be. And in the same way, we have an LLM doing that. We've got the output of our OCR, but then we pass it to an AI that then can analyze that in the context and understanding that this is a PIP2 application form, and this is likely what the claimant is talking about. So here you go. This is not easy to read. Here we have I'm going to show you the analysis history. So we process this PDF, and one of the things that we're able to do in that section that I showed you before, let me just go back there to show you the section. This box here, the original text, is that we were able to put that original script in that we used to write this form in there to give another AI that we have, which will act as a judge on our process, and it's going to evaluate how well we do with reading all the information, getting all the information correct, and putting it into the structures correctly. So if we go back to the dashboard, look at the analysis history, let's look at the report that we generated. It's telling us that it's got incomplete sections, and we know that because we only created a partial form here. This tool will analyze the entire form, and it'll do it correctly. So all we need is an actual form to process to see it working, but we don't have that. And as a result, we're not getting a point score from this. It's going to just score what it sees. So let's go down here. So what we can actually see from the accuracy evaluation is that the overall accuracy is 60%, details completeness 60%, and narrative accuracy 95%, which is very high. It's telling us what we've got here, areas for improvement, significant omission of key personal details. Now, most of this isn't actually to do with the OCR stage. It's to do with how we're structuring the data and handling it on to the final stage for creating the report. So most of these things, it's getting fine from the form. It's just that we're not structuring it correctly, and this is work that we can do later and to improve this if we wanted to get this perfect. And so it'll give you a list here of all the missing information, things that should have been on the form that didn't get on the form. And that's really helpful because it means we've got a metric that we can use, especially for these kind of LLM processes. Something that we want to maintain is that there are no hallucinations getting in, and that all of the information that we want to be in is there, and there's nothing missing. And so we can then set up these evals, which then compare a known input to the output and validate that our tool is doing consistently a good job. And as we go down here, we're going to see the actual output of the tool here. And so this is the kind of thing that the agent who's taking this claim on might get. Would be a form with the key information pulled out of it, the detected sections here. We've got the health professionals information. This is one of the things that it's missed out. It's not got all of the address information for the health professionals, even though it is there and it can see it in the form. It didn't structure it correctly. And again, here in the health conditions, it's missing the details. But you could see that the details that are there are really actually very good, and they match what we saw in the form. If we go down to the narrative part of the form here, this is where it's really powerful. It's able to make a deduction about how suitable and how applicable this narrative is to the scoring, and then it makes justifications for the descriptor that it's applied up here. It doesn't just give a summary, it shows you how it is justified that by evidencing it from the form. So it will be quoting different parts of the form. Now, some improvements that we could make to this would be to, for example, when you hover over this, you could then show the original form, the PDF, the section. So whoever is reviewing this would be able to physically look at the original content and go straight to it instead of having to search through the PDF and make sure that sentence really was there. But here is the raw extraction at the bottom, and you can see that it's pulled a whole load of information in there to populate the form. Obviously, there'll be way more in a full form, but it's doing a very good job already. So quite happy with how this one's turned out. It's got a lot of potential to be a very useful tool, and even as it stands right now, this would be a very helpful tool and asset to trying to sweep up the backlog of applications. So that's the first part of our design challenge done: getting AI to take a PIP2 form and process it so that it's faster, it's more consistent, and it's got full traceability. This isn't about replacing caseworkers. It's about giving them better tools, reducing their admin load, and helping clear the backlog so that applicants don't have to wait for months. In the next video, I'll walk through the second major challenge in this PIP journey, the assessment call, and show how transcription and AI can support the reporting and scoring process. If you found this interesting, feel free to like the video and subscribe if you want to get the follow-up videos. If you'd like to talk to us about the prototype or explore similar ideas, reach out to us at Continuata AI. Thanks for watching, and I'll see you in the next video.